let's talk about why I'm here. Why are we all here? I assume some of you came here to learn something. So a little bit about me. Now they shortened the sessions by about 5 minutes this year compared to previous years, so I'm going to fly a little bit so I can leave plenty of time for questions and maybe some demo if we can squeeze it in, if the network cooperates. But I am Joe Thompson. You may remember me from some of my previous talks at KubeCon, like please stop writing operators. We have enough. We don't need any. No, we actually do need some more, but I did that talk and it gets passed around occasionally. The other one that I did at scale, because I've actually come to believe this, is we need to destroy web PKI in order to save it. It's currently not working. I have links to those talks. I'm not going to belabor those points here. I've been in IT for about 30 years. The last decade or so have been mostly focused on Kubernetes. I have a list of previous employers there. And I currently work with a company called Clarity Business Solutions. You've probably never heard of it. We're a very small company based out of Linthicum, Maryland. And they just recently, I was a consulting engineer when I started there. They just recently changed my title to Cloud Native Architect, gave me fancy business cards, the whole deal. And there's some contact info on the right. Now don't worry, you can take a picture of this slide if you want. Don't worry, because at the end there's going to be a QR code and a tiny URL link that can go to the live slides on the web. And you'll be able to click all these links and copy and paste things and all manner of wonderful stuff. So, I always like to take the temperature of the audience a little bit when I start these. Who's at their first KubeCon? Hands up. Quite a lot. Yeah, it's usually 2/3, 3/4 of the room. Who here has been to KubeCon before? Okay, who's been working with Kubernetes more than a year? All right, more than 5 years. Okay, more than 15 years. See, okay. Sometimes I catch a couple liars in the room that way. If this is your first KubeCon, you may already know this from getting dehydrated yesterday. Drink more water. I have my water bottle here. If you don't have a water bottle, go to the CNCF store. They have these wonderful little water bottles there with logos on them and everything. Get one, use the bottle filler fountains. Keep that thing filled through the day. If you don't, you'll be dropping like flies by the afternoon. Now the other thing is, we're going to be talking about some low-level Linux features that power Kubernetes, but they aren't Kubernetes per se. They are things that were built into the Linux kernel mostly for other reasons. So who here knows about, has ever touched, has ever heard of these Linux features? Kernel namespaces. Okay, a few hands go up. I think probably some people have run into that with containers already. Control groups. Now, of the people who've ever heard of control groups, how many of you know it only from taking the Red Hat performance tuning exam? Okay, I see. That's where I found out about it. iptables, lots of hands usually go up. Everybody's had to debug that. Usually it makes you hate your life by the end of the day. Overlay file systems. Okay, a few people with that too. Yeah. So these are all the very basic things that kind of go into what makes Kubernetes actually work on a Linux node. Now what we're going to cover is basically how Linux puts your Kubernetes workloads into a box, but if they're in a box and they can't do anything or connect to anything, that's not very useful. So then how the Linux kernel connects them outside of the box to things like networking and storage so they can store persistent data and talk to other services and things like that. Now this is not going to be a full comprehensive overview. I could literally write an all day or all week workshop on the nitty-gritty details of all of these things. I'm just giving you a little taste here to give you an idea of some places to look and some of the things you might see when you look there. Okay, now why bother going this deep? Well, obviously because you're curious, right? That's always a good reason. But also, the more you know about the underpinnings of this stuff, I feel like at least, the more comfortable you'll be. It won't be a mystery anymore. You won't be going, what is going on? You'll know what's going on. And the other thing is, when you know what is running under the hood that is powering certain Kubernetes features, it gives you a little bit of a heads up. So if you know that cgroups is how Kubernetes handles things like resource constraints, requests and limits, then when you see that cgroups is migrating from v1 to v2, it kind of gives you a little bit of a preview, like, oh, that may either change some things about how we deploy our workloads now, or may give us new capabilities, as in fact it did. Now the other thing to note there is cgroups v2, if I recall correctly, actually predates Kubernetes, but it took a while for Kubernetes to build v2 support in because a lot of people weren't using cgroups v2 yet. So, mixed metaphors here. I kind of had a Wizard of Oz metaphor going, behind the curtain, the Wizard of Pods, ha. Okay, so the Wizard of Pods has a little pet. It's your workload. Isn't your workload cute? Look at him there. Now, if you have a bunch of those workloads in a Kubernetes cluster, and there's no isolation, if they're just all running around a big open space with piles of food and dishes of water around, it starts to look more like that. It's not terribly organized. It's going to be a mess to clean up after them. You know, you want to kind of start to separate them a little bit so that you can deal with them as individual entities. So you go to the wizard goes to the pet store. He wants something to put his workloads in. And now I have my little, does this have a green laser pointer? Yes, okay. So this is your pod. That's your workload. The pod itself is kind of your memory and storage. There's your CPU usage. That right there would be your service, connecting you to other things. You know, it actually works as a metaphor, I think. So, let's talk about some of the fundamentals here. cgroups and namespaces, and these are kind of one of the reasons we call it a container, because they contain your workloads to make sure that they aren't just doing anything they want with anything they want. Kernel namespaces, there are several of them. The first one to come out was the mount namespace. Now we're going to talk about mounts a little bit later. Mounts are one of the oldest concepts in Unix-like operating systems. But somebody around 2002 said, wouldn't it be cool if different processes could have a different idea of what file systems are mounted that they can see? Or more specifically, wouldn't it be cool if an administrator could give them a different idea so that not everything can see every mounted file system? Well, once you've got that idea of wouldn't it be nice, there are other things that you go, wouldn't it be nice if we could do that and that and that? So there's the UTS namespace, the IPC namespace, PID, network, user, UIDs. The most recent one is the time namespace. That is a relatively new one. You can now give a process in a container literally a different idea of what time and date it is, if there's some reason you need to do that. From what I understand, it's not so much that you want to give them a different idea of the time and date, it's more about keeping things synchronized after things have been suspended and then resumed. And so you get a separate view of an aspect of the system. Now, these are separate types of namespaces, and processes can be in namespaces together or namespaces apart, depending on what namespace it is. And if I have time to do a demo later, you'll actually see an example where two containers in a pod, by default, will share the same network namespace, because that's how pods work by definition. But each container has its own mount namespace, because again, by default, that's how things work. And where you see it, and for each one of these, I tried to give you an idea of like when you're going back and looking at these slides, because nobody's going to remember things like specific file system paths when they walk out of here. There's too much info at KubeCon for you to keep that in your head. But when you're coming back and looking at these slides later, you can go on a host. You can just go in the proc file system. You'll get proc, process ID, NS, and then under NS, there's all the different NS types. And they're actually links that point to the indicator for the namespace. Now, control groups, they kind of came out of Google. Google was working on, I wonder what Google was working on around 2006, that they might want to confine processes into separate resource domains for. I think probably a few people here have heard of Borg, right? I don't know this for certain, but I feel pretty sure that one of the foundational things when they were writing Borg was they went, we need to be able to do this, and the kernel can't do it yet. So they wrote the code to do it. They contributed it to the Linux kernel. It got merged in 2007. Now remember, this is way before Kubernetes. It's way before Docker. I mean, even like LXC, which came before Docker, was a relatively new container system at that point. And so what cgroups does is it creates a hierarchy, they call them slices, of resource limits and allocations and weights and all kinds of different controls you have for each different kind of resource that a process might need to consume. And so if you go into the cgroup hierarchy, you know, it's under sysfs cgroup. If you go into the cgroup hierarchy and you go down through the slices, you'll actually see like a slice under, it's named like kates.io, and then that's for all the pods that are running on that system. And then you'll see under that, there will be a slice for each pod quality of service. If you don't know about quality of service, go look it up after this. I decided not to go into the deep details of it, but it's very interesting. And if you change a pod, or if you recreate a pod so it has a new quality of service, you will actually see it move from one slice of the cgroup hierarchy to the other slice based on its new quality of service. Like I said, the current version is cgroups version 2. It's actually been around for a while. It just took a long time for Kubernetes to really fully support it. And I think that was because it took a long time for people out in the world to adopt it, to start running versions of Linux that actually had support for it built in and enabled by default. So, networking. Let's start connecting up those isolated processes. iptables. Now, iptables we've had for a while. There was a thing before iptables. Anybody know what we had before iptables? IP chains. I heard it from all over. Some of you guys have been around for a while. So we had IP chains, then it was iptables. Right around the time iptables came out, there was something else that came out called IPVS, and it was intended more as a load balancer than a filter. But when Kubernetes came along, it actually supported both of them as different modes, and one of the reasons it did that was because as you start adding more services to a Kubernetes cluster and the iptables rules lists get longer and longer and longer, they take longer to process, whereas IPVS works differently. Okay, so in an effort to kind of break that scaling issue, they supported IPVS. Now, what happened later was NF tables came along because the Linux kernel had the same problem Kubernetes had, right? As people started implementing more and more complex IP chains, their systems were slowing down, their packet filtering was slowing down, they were going, we need something else. So NF tables works differently. It kind of pre-calculates the rule chains, so you just evaluate a packet once, and you get a yes or no, or it gets forwarded to a destination or whatever, instead of just going rule by rule by rule by rule down the IP chains. So Kubernetes supports all of these. I think by default, it's still in iptables, but NF tables will probably become the default soon. And so, if you look at iptables on a host, and you do it's in the NAT table usually, where you'll see all these rules that direct traffic coming from your services. One of the things that has changed here over time is, it used to be the kube proxy was an actual proxy. It would start up on your host, you would create a service, the kube proxy would create the iptables rules, and they would forward that traffic to the kube proxy. And the kube proxy would then direct that traffic wherever it needed to go into the containers on the host. Later, the kube proxy stopped being an actual proxy and everything was done through iptables, but it still would open up that listen port, right? But it wasn't actually used. Then later they dropped the listen port, so now if you go on a host, there is no actual listen port. Like if you open a node port service, there's no longer even a listen port anymore. It's all done through iptables rules. So all those service addresses and ports, they're actually kind of fictitious. Because the only way you can see them on the host, you can't see them in a listening port, you can't see them in an interface, you can't see them in an assigned address. They're just a function of iptables. Now this one depends, right? This is always where you start to get into, you will see when you do things in Kubernetes that it will affect things like routing, and sometimes it will affect network interfaces. If anybody here remembers how Flannel used to do things, Flannel would have a bridge on the host, And then for every container, that container would get an interface that was, connected to that bridge. And that bridge on the host had its own IP, and every interface inside the containers had their own IP. And Flannel would set up routing rules between the host and the cluster, so you would actually see kind of what was going on. Now, with a lot of the more modern CNIs, you don't see that anymore, or you see it implemented differently. So what you see will depend on what your CNI is and what you've been doing in your cluster. But the basic stuff that you're going to use to see it is still the same old tools. It's route, it's IP adder, or IP route. Some hosts don't have the old route command anymore. And you can run that in, if you have a shell, you can run that inside your containers. You can always run it on your host, and you'll be able to see what your CNI is doing. For example, one of the things that you will see if you run IP adder on an EKS node is you will actually see additional addresses attached that come out of your VPC subnet pool, because that's how the AWS VPC CNI works. It actually connects virtual Amazon AWS interfaces with addresses from your subnet to power your container IPs. So in a lot of Kubernetes clusters, you'll see like the pod IPs will be different from the host IPs, but not in EKS because of the way that works. Here's where the fun one comes in, data storage. Basic mounts, okay? So the idea of a mount, it's so old I couldn't even find out how old it was. Everything I looked at told me a different, one of them said it was in Unix v1, like the original release of AT&T Unix. Another one said it came along in v5, another one said it came along in v6. I'm just assuming it's so old nobody really knows. Like, once you go back past Unix version 4, it starts to get a little bit muddy. But it's one of the oldest things in Unix-like file systems, and the whole idea of a mount is you have a file system on a device, and you want to plug it into an existing file system. Now, the way that works, anybody here ever mount a file system over files that they needed? Yeah, I've done it too. If you mount a file system at a location on the parent file system that has files in it already, they will be masked. They will still be there, but all you will be able to see and interact with in the normal shell is the files in the child file system, okay? Now, mounts work the same way in a container as they do on the host. You can have a device, you can mount it at a location, et cetera, et cetera. That's how secrets work, okay? Secrets are the data from a secret, if you mount it as a volume, is injected into a temp-fs that is then mounted inside the container. And you can actually see that. It actually says like kubernetes.io/secrets or whatever. When you look at your mounts, you will see that device, that temp-fs, and that's where the secret data is injected. And the reason for that is because as a temp-fs, it's never written to persistent storage. So when that container goes away, all the secret data that it had mounted goes away, which is what you want. Config maps work differently. Config maps are actually injected. I actually had a discussion with somebody in Slack a couple of days ago because I was writing this slide, one of the last slides that I wrote, and I was going, how in the heck do the config map files even get in there? And it was, well, there's this piece of code, I think it's in the kubelet, and it actually injects those files into the container overlay file system, which I'll talk about in a minute. It injects them into the container overlay file system. So they actually are written to a persistent location on the host, but it kind of goes away when the container gets cleaned up. But if you want something to not hit the host at all and never be written to disk, you need to write it as a secret, not as a config map. And then you have PVs. Your typical PV is going to be just a physical volume, like an EBS block device. You see that all the time with stateful sets. They create a PV, they attach that PV. If you go look in that container, you will usually see that block device pass through to the container and mounted. So it'll just be a regular file system inside the container. And you usually can see that block device outside on the host too. It's just not mounted in the host's mount namespace. Okay, so now we get to overlay file systems. Remember I said a mount masks anything that it's mounted over. Overlay file systems were somebody going, wouldn't it be cool if that wasn't the way it worked? What if we could create a layer and just add that layer on top? Now, there's some side effects of that I don't want to get into because we are short on time, and I want to be able to do some Q&A. But what if you could have, instead of the file system masking what's under it, what if what's under it could show through? Thanks, got the 10-minute time check. What if what's under it could show through? And what if you could add more layers on top of it when you needed to make a change, and so on? And what that does is it eventually becomes other files. It was originally UnionFS, AUFS came out, another UnionFS came out and improved on UnionFS, then OverlayFS came out, and that also gave us kind of the concept of container image layers, right? Now, the image layers don't necessarily directly correspond to actual overlay file system layers, but if you go and you look, like if you have a container image that has a layer that just adds a file, and you go and you look at the mounts on the host, you will see those overlay mounts, and you will see that one of the layers of the overlay is made up of a whole bunch of snapshots aggregated together, and one of those snapshots will be from that layer that added that file to the container, or whatever it did. It might have installed a package and some files got written, whatever the case may be. The nice thing about layers in containers is we're kind of leveraging that idea of if it's the same thing and it's the same files and they're in the same place and they have the same contents, we don't need to store them twice. We just store the layer once and then we reference it. We can apply that layer over the base image of the container. And when you download an image, or when a container runs and an image gets pulled and unpacked, you'll actually see all that stuff being unpacked under usually wherever your container runtime's working directory for that is. If it's containerd, it's varlib containerd. Okay, so let me see if I can. Like I said, the Wi-Fi's been kind of janky, so I'm going to try and full screen this. Okay, so what I have, am I still logged in here? No, I'm not logged in there. Let me see if I can come back up. This is, you can actually see some of these mounts here. I just want to come back to, oh, okay, I can do it here. Okay, so where was my IP that I logged into? Was, bear with me one second here. Okay, it was 54.224. Okay, so it's the same one. Okay, and now I'm in. Okay, so we are a little short on time. I want to do some Q&A, but I do want to show you at least one thing. Show of hands, who wants to see a mounted block device in a container? Okay. Who wants to see iptables rules that make a service work? Okay, maybe a few more there. Who wants to see where the limits and stuff are expressed on the cgroup hierarchy? Okay, I think we'll do the service because that's real easy to do on the fly, and I think that was the one that won the vote. So, like I said, I have all these things now. Over here I have my, I can do kube control, get service. See, I'm doing this on the fly. Okay, so I have a few services here. Now, I created a couple of these just for this demo. This Nginx curtain service I created just for this demo. So if I go over here and I look at my host, actually I'm over here, I'm looking at my host. Okay, first I want to give you kind of the unfiltered view. -L, -N. Okay, lots of messy rules. They're doing all kinds of things. They're shifting packets everywhere. Let's do a little grepping. Okay. Oh. Did that service not get through here? Maybe not. Oh, I see. It has no cluster IP because it's part of a stateful set. I'll do a different one. I'll do metrics server. Okay. Let's do metrics server. Okay. Okay, so you can see, now this is on the host. This is not in the container. This is all the iptables rules on the host that make that metrics server, and you can see the port name there too. This is all the rules that make that metrics server service actually work. Okay? So hopefully you never have to go into a host that's running and go in and debug the Kubernetes service iptables rules. But if you ever do need to debug something, or somebody says, what is going on? Or like your security people are going, where are all these weird rules? Because they don't know about Kubernetes. Then you can give them an answer and go, hey, that's for our Kubernetes cluster. It's totally cool. Just ignore that one that says Bitcoin-miner. That's a separate thing of mine. It's all right. Okay, so it is 11:25. Now, I want to fly through a couple more slides here. Nothing super detailed, just a couple of final thoughts. The first big final thought is there is no magic here. I've said that in a lot of my talks at KubeCon. These things are knowable, and you can know them, okay? Even if you are a brand new novice to Kubernetes, even if you're a brand new novice to Linux, it's all there. You just have to know where to start looking to find out. Okay? The second thing is, most of what's going on here, iptables, that's super old. Mounts, super old. Like even cgroups are pretty old. And they're just about the newest thing that we looked at here. They're several years before Kubernetes. So none of this is brand new stuff. I mean, there is some stuff going on in Kubernetes, like when you deploy a service mesh. That has more to do with what's going on in your containers in the cluster than it does with what's going on the host specifically. But if you look at the host, you'll see stuff that makes those service mesh containers work. So it's always worth looking under the hood to see what's going on. Now, I'm not going to read all this to you. It's links, so you can go to the live slides later and you can see those links. Thank you very much. We've got about 3 minutes left, so if anybody has, I think we have time for 1 or 2 quick questions. The QR code on the left goes to these slides. The QR code on the right is for feedback on the talk. Please be nice. I hope it was useful. So if we have any questions, I think, do we have mics out in the audience anywhere? Or should people just yell? I guess just yell really loud. Anybody? Go ahead.
What Linux are you running on your laptop there?
That is actually Fedora. Now, I have not upgraded it to what is the latest is Fedora 43, I think, that just got released. But yeah, this is like Fedora 42. I think if I cat that's the OS release, it'll tell us. Yeah, Fedora 42. Let me go back to the slide. Anybody else? I don't know if I would say issues. cgroups v2 allows some new capabilities, like one of the capabilities is what they call memory throttling, where it will try to free up memory on the host as memory starts getting more consumed. And I'm talking off the top of my head, so I apologize if I say anything wrong here. But there are new capabilities in cgroups v2, and I believe some of them, they aren't necessarily directly targeted at Java, but they make Java workloads a little bit less tense to run, because they improve the host memory management. I think one of the other capabilities of that memory throttling is that you can actually interrogate the system and see when memory is getting tight, so you can act proactively rather than just going, oh, my app got killed, what happened? What's that? That I don't know about. Anybody else? Yeah, go ahead. You and then you.
Set up a service, a node port service. Does it set up at the iptables on every node?
It does. Yes, the kube proxy will have to do that.
And then a follow-up on that. Does it forward it into the actual, is there an actual service on the container network that it gets sent to?
I believe it gets, I believe at this point, like I said, it used to go through kube proxy. I believe at this point it goes directly into the container. So as soon as the kernel sees that packet come in, it runs it through the filtering rules, and the filtering rules say it goes to this process, which is the containerized process.
So if I have something that gets sent to a node where the pod actually isn't running, left forwarded to somewhere else?
Yes, it will go somewhere else. Like if a packet hits that node, it will get forwarded to another node. Yeah. And then you had one? No particular reason, I just happen to have some Terraform laying around that spins up EKS real easy. Yeah, it was easy to, it's actually a repo I have called Simple EKS. I'll pull it up here if anybody wants to copy it. And I have actually thought about doing the same thing for GKE and AKS and stuff like that. Yeah, so that's the repo right there that I used to spin up the EKS for that demo. I did find one bug, which is I need to add something when you set up public nodes. My firewall is a little bit too tight by default, so they can never register because they have to come through the public interface and they're not allowed to. So for now, the default configuration works, but you might want to wait for me to send up another commit to fix that. I think that's 1 minute past. I'll be around for anybody that misses me out in the hall. I'll be at the puppy petting thing, which I think is like 12 in one of the lobbies. It's on the schedule. Go find it. Drink more water. Go pet some puppies. Get some lunch. Thank you.